Very helpful. Our next speaker is just an all-around awesome dude. And you guys, if you're going to be here for this session and into the next one, you're speaking. I'm sorry, I didn't.
Oh yeah.
Yeah. Leon is he's currently at VF Corp, but I have this recollection of being at one of the early MacTech conferences, and we were at the Griffith Observatory, and they started talking about the massive amounts of storage that they were needing in there, and I think Leon actually reached into his pocket and pulled out that amount. No, I'm not sure if it was, but it felt like that at the time. But at Broad, when he was at Broad, they dealt with these massive amounts of storage. It was really quite incredible doing. They're doing some very cool stuff at VF Corp, and I have found that Leon is has an incredible way of explaining things. And he's spoken at a number of our pro events and conference a number of times. And if you don't get a chance to talk to him today, make sure you go up and shake his hand and introduce yourself. And have I set the bar high enough for you?
That's fine. That's
yes.
fine.
So Leon's going to talk about command line and how you're going to turn this into a toolkit.
I can do that. So we're going to go over a little bit of Unix, but I'm going to start off by, Neil touched on my experience with storage. I just want to share a little bit about that. Prior to working at VF Corporation, I worked at a place, some of you may have heard of MIT. It's a small university. It's been known for producing a few brilliant engineers and scientists. So no, I did not go to MIT. I worked there. I always joke about, I worked at MIT, so does the janitor. Right? So it doesn't mean anything other than I was able to work at a very prestigious institution. So when I got hired by MIT, they actually took me and put me into the Broad Institute, which you may or may not be familiar with. It's more of a life sciences type company. They're known for developing the human genome. They're actually the ones who actually solved it for the very end. It was a big race towards the very end to get it into the public domain as opposed to a private, something you'd have to pay for. So the gentleman who was the director of the institute I worked at actually fought really hard. He was actually not a bio-research guy. He was actually a mathematician, and he figured it out. And we created the Broad, and I was part of that for almost 11 years. And when we talk about storage, and I'll get to my presentation quickly, is when I attended that event and I remember that because I was sitting there and the presenter was talking about how much storage they have. And I was sitting there and I remember my buddy Andy, who's actually the conference chair here, he's like, "You have more than that, don't you?" And I went, "Yeah, by a X amount." So he actually outed me and said, no, you want to talk about storage, talk to me, meaning myself, because at the time we had 6 petabytes of storage, and they were talking about having maybe close to a petabyte. So if you don't know what a petabyte is, it's a scale of storage. So you go gig, how do you get to 1,000 gigs? That's a terabyte. 1,000 terabytes is a petabyte. When you have 1,000 petabytes, you got a exabyte. So when I left the Broad, I was managing storage in the realm of 30 petabytes on site and probably 16 in the cloud. So when I talk about knowing how to deal with large amounts of storage, yeah, I am very familiar with it. I'm not the person who made it all happen. I was part of a team. But yeah, so I got a real opportunity to learn and grow with that job. And I want to share some of the things I've learned at that job with you here about going into Unix and terminal. Because if you're not really familiar with using terminal or shells to make your life easier, really want to help you do that. I've trained probably a half dozen people in just how to use command line basics through the years, through taking the help desk staff and saying, all right, you know how to do it through the GUI, let me show you how we can do it through terminal. So we're going to cover some basic terminal commands. We're going to look at some of the commands. We're going to tell you what's running. We're going to look and see how to work remotely on a user system. And throughout I'm going to show you a couple favorite tips I have, and I'll reserve some time afterwards for questions and answers. But don't feel bad if we don't have time for that. You know, hunt me down. I'm here. I'm more than happy to sit with anybody and kind of go over some of the stuff. This is a precursor to the next session that I'm running, which is going to be more advanced tools. So if you feel like this is kind of a little low ball for you, it's building. All right? I have a plan for everything I present. So let's look. All right. So for those of you who get your computers with you, and I'm glad to see so many of them here with it, go ahead and open up in Terminal. So when we look at Terminal, what is it? Well, really what it is a shell. We call it Terminal because that's what the name of the app is, but it's a shell. And what's the shell that we're working in? Well, we're using what's probably defined as Bash by default on all the Macs, but there are different types of shells that are available. There's C shell, there's Z shell. They all have different roles and purposes. All right? But when you launched your Terminal app, the first thing you did is you got a prompt. Now, your prompt's not going to look like my prompt because that was from a system I actually was doing this on. So when I captured it, but so I want you to see something. There's quite a bit of information there, and I haven't done anything. Now, what's there? Well, we can see that I know the name of the system that I'm on. That's the first thing that presents to me. And then I could see that I have a tilde there, which tells me where my location is. Okay? In Unix, a tilde off is a shortcut way of saying my home directory. All right? Next thing I can see is the user that I am. So that is my Unix short name or my Mac short name. So that, you know, what the company issued me, that's my login. And the next thing I see is a $sign. So I've learned 4 basic functions just by launching the Terminal app. I know my machine name, I know where I am, and who I am, and what I'm able to do. So right away I know that anything I type after the $sign, and once I hit a return, that means I can execute it. That means I can run that command, if it's a true command. If I type gibberish, I'm going to get, I don't know. Now, I mentioned to you that the tilde is a shortcut for saying my home directory. So I want to introduce you to your first command, and that's pwd. So pwd is a way of saying, show me where I am. All right, so if you're not familiar already, so I typed in the command, and it showed me that I am at /users/my name. Now, what does that mean? So the pwd command tells me that I am actually going from the root of the system forward. So I now know, hey, I'm right where I'm supposed to be. I just confirmed it, so the tilde is telling me I'm in my home directory. Now, if I was not in that location, let's say I was in somewhere else, right? So I put that up on the screen here. So you can see my machine. I have a slash now, okay? I have my name, and I have a $sign. So I'm still, so what am I learning? I'm learning that now I am at the root of the directory. So if I wanted to confirm that, so I could look and say, well, you know, if I change my directory, so I introduced a new command here, cd, so I go /users, my home name, right? It would actually take me back, and notice the tilde shows back up. All right? So if I changed it back to the slash, so I put myself back at root, so I went cd/, right, and hit return, it would take me to that location. Now if I do a cd and a tilde, now when I look, I see it put me right back in. So I didn't have to type in the full path. I didn't have to say users, my name. All right? It's a quick little thing that people often just don't take information from. They just glance at it and they don't really realize what they have. So that tilde is a very powerful command in itself, and it's scriptable. So it's really cool in that sense. So you can say, yeah, you know, if I put a tilde in it, it understands whatever user I'm in, it's going to take me to that home directory. Hello. Okay. That's better. Yeah, we're getting a little delay here. This is the bane of working in beta software. Wow. All right, let me jump out for a second. Come on. Always fun. Okay. Okay. Now let's look at what files reside under our home directory, and we can achieve this by executing a new command. We're going to look at ls. Now, when I do the ls against my home directory, you'll see that it lists a bunch of things, and it puts them in a kind of a jumbled mess. It just puts it out there. So I can see applications, Dropbox, OneDrive. So I got a desktop, I got a library, I got a public, looks like a folder maybe, a documents, movies, downloads, music, right? So I see a bunch of stuff there, but it doesn't tell me whether they're directories or they're files, because all the command did was tell me what it sees underneath. I don't know what type it is. So what I really want to do is I want to make sure I understand what I have into my directory, and I want to know whether it's a file or a directory itself. So I'm going to add a verb to the command. And that's important. So there's a new concept here. So I'm looking and I'm building out, I'm saying a lot of commands have actionable verbs. So they're often called flags. So I'm going to say -L. So when I do an ls space -L, when I do that, now when you're looking to look at the output, you can see I have applications created. So everything I was seeing before jumbled together is now listed out, and it shows me, okay, I've got DRWX. So I can see that that's a directory, and it tells me the permissions on it. If I look at the next column over, it tells me who the owner is. Look at the next column, it tells me what the group is. Anybody here understand why the group is a number? Sure.
Probably joined a directory service.
Yeah, it's a directory service which it can't read right now, so because it's offline from it. So it looks at it, it just tells me what the GID number is, right? So that's important, because if I wanted to go and change the permissions, which we'll talk about, I could actually just type that number in, and it would understand what I was doing, all right? Now, again, looking at the permissions, notice I got a directory that tells me I got read, write, and execute. Some of them say read, write, execute, and then there's a dash, then there's an execute, read and execute, and another one that's read and execute. What that really is telling me is there's a concept in Unix of POSIX commands, and that is user group another, right? Or owner group another, right? Those are important because that's how the basics of the Unix system works. Now, when you get into more advanced levels of dealing with storage, there's more options. But we're not going to go into that here, but I wanted you to be aware of that. So when I look at something, I can say, okay, so my desktop is a directory, and the owner has read, write, and execute. And when I say execute, what does that mean? It means I can search through it. I can run a command against it, all right? It always, you know, when the early days of me dealing with Unix, I was like, I don't know what the heck X means. Right? It's really what it's for. So when I look at something, if I want to be able to search through it, I need to be able to execute through it. All right? So when I look at now, I see I got directory, read, write, execute, and group is nothing, other is nothing. The importance of other is if they're not listed as a user or a member of a group, what do we allow them to do? All right? So in this case, my desktop is only available to me and nobody else. But if I look further down, I can see that the directory of Foundry Analytics, and that's a program that I use, right? It has, I get full rights to it, and then the members of the groups that are on my computer have read and execute, so they can read it and they can go through it, and the same thing for others, all right? So, and there are a bunch of other things. There You'll see there's an @ sign and there's plus signs. Those mean special things, but I don't want to get into too much depth here on that. Those mean something, but I want you to see that those DRWX, that's expressible as an octal number. So if we wanted to translate that into something as a number system, that would be a 7. Okay? A read and execute is a 5. Right? And it's like, well, how am I going to know that? I don't live and breathe this stuff. So it's like, well, there's a cool tool to do that for you. And I really encourage you to find and bookmark that. Right? Because this tool will help you to learn what that is. Right? So you notice here I put in the annotation saying the user needs to have read, write, and execute. The group is read and execute. Other is read and execute. And it shows me a 0755. Now, the 0 doesn't need to be put in. The 0 is there for another reason. Right? That command, when we get into more special features related to using the POSIX commands, when we get into big types of storage and more levels of sophistication, we use additional items like setting the UID or setting the GID or a sticky bit, right? This tool will actually teach you all about that. And it's a great way to play and say, well, what happens? What is this? Right? You can actually go through and play scenarios, and you can take a directory and you can go through and say, you know what? I want to set the sticky bit. Now, why would I set the sticky bit? Well, the sticky bit could say, you know what, I want to make sure that every directory that's created under this path inherits those permissions. I could set the sticky bit, right? But let's talk about permissions. Now, there are 2 permissions commands or types of commands we want to use when we're working inside a directory, and we want to say we want to have ownership, or we want to change what the actual owner can do or group can do. So if you look at the first command I typed in, it was like chown, C-H-O-W-N, right? Change owner. So in the change owner command, I can actually specify a new owner, colon, new group if I wanted, and then I can say, put the path, the file name in the directory. That's really handy, right? Now, if I just wanted to change who the owner is, I wouldn't have to put the group in. I could just say new, chown, new owner, and the path, and it would take that and say. Now, if I put an -R on that command, that's going to say anything from that path down is now going to receive that command also. So that's an important concept also for you to gather and understand, is that when we execute commands, it's at one level unless we specify traverse the paths. So anything that's underneath. So what would be underneath? Well, anything you had underneath, files and folders under the path you're working in. So if I was in, let's say, documents, and I said change the owner of everything inside the documents folder recursively to, Neil, it would go through and say, okay, is Neil an identified user? Do I know who Neil is? Because if it doesn't know who Neil is, it can't do it. It might do it, but it's going to come up with a weird error if I try to do something. So, but let's say Neil's on my system. I can actually go through and say, yep, all right, so I now have made that change, and I lost permissions to ownership of that directory because I recursively changed it to somebody else. Now, if I may still maintain my ability to see it and do certain things in it because I belong to the group that owns that also, unless I go in and change the permission. But I wanted to show you this neat little command, chmod, or change mode. Now notice here I put 777 in. That's not a normal option for changing the permissions for something. This is what we call full world read writable, meaning there is no restrictions. Anybody and everybody can do anything to it. Right? So what I'm saying there is, owner can do anything, group can do anything, and unidentified people can do anything other. Right? So in the early days, I would see that on web directories. Because at the early days of the web, it was like, yeah, it had to be read-writable by everybody, and they were trying to figure it out. And I'd go through and say, that's not good, because somebody could hack your website and actually make the changes from outside if they could figure out how to get to it. So that's not a normal option, but I show it to you because it's what we call full read-writable. Right? All right, so we're back to my home directory, and I'm listing it out. And you notice I use the ls-l, so you know I see the permissions. Okay? But notice I don't see any files. I see a bunch of directories, but I don't see any files. Well, so plain and simple, there just isn't any files in this directory right now. But is there anything else? All right? And I go, well, I did the long command, and it's going to show me everything that's in the directory. That's a true statement, except for items that are hidden. Now, the Mac leverages this to the hilt. It has a way of saying it wants a bunch of stuff that it doesn't want you seeing on a normal basis. Right? In my Linux world, we don't, when I go in, I'm seeing everything all the time. I see every file. But on the Mac, they're trying to hide things because what they're doing is they're trying to prevent people from damaging their system or touching things that they just don't really understand. All right. So when I type in the next part of the verb, which is A, which stands for all, so list all files, now notice what I see. I see I see dot, 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 and I'm seeing, oh, look at that. I got CF user text encoding, a .ds store. What's a DS store? All right. It's where the settings is when you look at something in the GUI, it stores the information the last way you viewed it. That's where it puts that information, right? .trash, we're going to explore that a little bit. .bash history, right? So every time you type a bash command or anything in the shell, it actually puts it in a history file, and it's actually stored in that location. It shows you your sessions, right? You can actually go through it, and there's a config file, there's cops Dropbox. You can see a bunch of stuff there, including .ssh, right? So these are all things that are either config files or directories that are hidden on purpose, right? So now I've exposed them, and I want you to see that. So, when I did it before, when I looked at it, I'd only saw, applications down, but now I see everything. Now, if I put something in the trash, right? So let's say I created a file, and I threw it away in that user's account, and when I went into my GUI, I would actually see it in the trash can, all right? So, and when I opened it up, I would see, oh, it's temp trash, right? So I created this file called temptrash.txt, right? And I'm going, yeah, I threw it away, and it's there. But when I now go through the terminal and look at it, I'm going to CD into the trash directory, which was hidden. And notice when I do an LSAL, I can see now there's a .ds store file, because it automatically creates it to show me when I looked at it in the GUI. And notice now I can see my file that's in the trash. All right? So every time somebody throws something in the trash, that's actually where it puts it. Now, what's interesting about that is if I have 10 users on the system and one of them throws a file away that's critical to all the other 9 users, they can't find it because it's not in their trash. It's in this user's trash. All right? So we're going to show you a little bit about that. Now, I want to mention something. If I'm going to look at something that's in the trash and it's not in a directory that I own, I can't get to it unless I do something to the permissions. So I either have to go through and take ownership of that directory so I can see what's inside of it, or I have to go in and change myself to be a pseudo user or root user. All right? I'm not going to get into too much depth here. I'm going to reserve some of that for later, right? But I wanted to bring it up here because I don't want you to mislead you on a concept, right? I'm working in my directory that I fully own. I put a file in the trash. I can see it, but I want to move it out so others can see it now. Now, if I want to move this file from its current location, so I'm going to CD into the trash, And you notice I spell it out, so it's like, okay, I know I'm there, right? And now I want to move it from the trash to the desktop of the current user. Now I want to do this by actually, going through, and you notice the command on the second line of down. So it says mv temptrash.txt/users/Lincoln/desktop, and I put a dot in, meaning put it there. All right. So what I'm saying is that command is, there's a new command I'm introducing to you, and that's mv. That command is used to move a file. It's also a way of neatly saying, I want to rename the file. So if I wanted to rename this temp trash file, I could say mv, as long as I was in that directory, I could say mv, the file name, new file name. It would actually rename the file. It actually doesn't really move it, it just renamed it. But if I put in a path of where I want to put it, it'll actually move it. If I actually go through and say mv this file to this path, and I give it a new name, it'll move it and rename it. All right? Now you can move lots of things, but you have to make sure you're using the proper commands to do this right. This is in reference to saying, a lot of people think, I just want to copy the file. That's a different command, right? And if I say copy here, it's going to leave it in the trash, and it's also going to put it where I tell it. Well, that's really not what I want. I really want to move the file. Okay? So let's go back and look. Now you can see that at the last grouping of commands, I say, you know what? I move the file, and now I want to confirm that it's actually at that location, so I cd to the desktop, I ls out and say, yep, there's my file. I moved it. Right? If I go back, right? So now I want to go back and say, tell me where I am. All right, so I went back into my trash, and now I say, let's look here. You can see I got a concept here of cd ... And then I'm saying is I want to go back up a layer, and that's a new concept, right? So ... is a quick way of saying wherever I am, go and bring me up one level, right? That's in Unix, because everything has to be explicitly expressed, right? There's no GUI of like drag and drop. It's all terminal command. So we have little tricks to say, let's go up a layer. Even if I don't remember what's above me, I can say, give me that next layer above me. And then I can, so you can see this is indication. I said, give me an ls-a. And what it did was it actually showed me, right? Again, it's this cluster. It shows me all the hidden files and folders here. Right. Now, the double dot is really cool in the sense that, let's say I want to, I'm going to go back and say I'm at this level. If I go cd ... what am I saying? I'm actually nesting two layer up commands saying go up one layer and go up again. So I don't have to know what's there to quickly go up two levels. All right, and in this case, when I say what happens when I did that, I do the long, it shows me I went right from one directory up to the users folder. Okay? So that was important. I could sit there and go cd ... /////// and it would take me as far up. If it took 3 to go back to root, it would take me to root, or it would take me up 3 layers. All right? This is really handy when I'm working deep down in a directory and I can't remember what's above me when I'm working in terminal, and which is very common, right? As I'm navigating through, I don't have a photographic memory. I don't remember what I just went through. I could scroll back in my history, but quickly I can just go, bring me up a layer, do an ls. It's like, no, that's not what I want. Go back up a layer. You know what? I'm going to go back 2 layers. There's where I want. All right? It's a lot shorter, right, than typing out the full path statement. That's a great comment, right? Because that's what it really is for is, you know what, I can go anywhere with the cd command, but do I really want to express, this massive path statement? Or just go cd ... // and just keep going up? Sure.
Go like, for instance, in this situation,
Well, you can't get past root.
Will it stay at where it is now, or will it go to the root?
No, whatever it is. So if that is where root is, meaning slash, that's where it'll end. So I could actually put in like 15 of those. It's not going to go past slash.
Yes, but when I do the command, will it stay where it is because it was an error, kind of, or will it go to root?
Well, it'll go as far back as it can and stay there.
It'll go to root.
Right, right. It'll stay where you. So it again. So the question is, if I go back past where it really is existing, where does it go? It goes back to slash, which is root, and it'll stay there. There's no such thing as going past root, right? That would be interesting. It'd be like, look at, I just broke the fourth wall. I'm into something new. All right. Yeah. So, all right. So now I brought you here because I wanted you to see that we're going to move a file to a special directory called shared. Right, so I'm going to move on. I'm going to say, so when I went to cd/users, I do an ls long. Now I see that there's a shared directory that I want to get to. Every system that is on right now has that shared directory. This shared directory is very special in the sense that it has special permissions attached to it. Any and all files that are placed inside of it are fully read-writable or read and executable. So basically all users should be able to see it. Now it can inherit permissions that says they can't make a change to it, but they can at least see it, and through terminal we could actually fix the permissions because I've shown you that. Right. So let's look at it and say, okay, so I've given you a little summary here. So I've introduced the pwd command, so I've told you how to identify your path. I've shown you the cd command. I've shown you the ls command. And I've shown you the ls command with a couple verbs or flags. So L for being long, A for hidden. And if I can put them together, so I don't have to type them out, -L, -A, I can just put -LA or AL. It doesn't care because they're all valid. All right. I showed you the chown command. I showed you the chmod. And I showed you the move command. So we've done here is I've actually given you a core foundation of saying you know how to work in the basics of terminal. Now there's much more to terminal, and I'm going to show you a couple things, but I've given you the foundation that if you actually went back and just ran through these examples, you could teach anybody the basics of working inside terminal. Right? And then as we grow and expand, we'll introduce more and more commands and more functions. Like we didn't even go over the text editor. We didn't go over a bunch of different things. But I wanted you to see, like, in my world, one of the hardest things for me to deal with is I have to jump in on people's computers, and I'm not allowed to do it through the GUI. So so think about that. Right? I have users around the world, and they tell me I can't, the security says, no, I can't remote into their systems and be with them at the same time. So something like ARD is not an option for me a lot of times. I do have the tool available, but what happens is my users have a history of like, yeah, I'm going to jump on the system with you. They leave and don't tell me. Right? And I'm handling, 4 and 5 calls at once sometimes. And by the time I get back to them, their screen's locked and I can't unlock it because that's how security wants it. All right? They're gone. And I don't know their password. It's like, well, they'll tell me their password. And I go, no, I don't want to know your password. I don't want it. I just don't want that responsibility. I want to, terminal bypasses that problem for me. I don't need to, I always tell them, I'm like, listen, I'm going to go on your computer under the hood. All I need to tell you is please do not reboot while I'm on your machine. Because I might be trying to do something and you just knocked me off. All right? Because I've had that happen. I've had users that would turn around and be like, yeah, go ahead, and I'm like, oh, yeah, you threw me off. It's like, half an hour later when I finally get them to come back, and it's like, you done? I was like, well, I would have been, but you rebooted the computer and I lost access. It's like, oh, I didn't know that mattered. Okay, now you do. All right? Don't reboot the system while I'm on it, because you can't tell I'm there. All right? Now, I want to show you a little trick here. This is a little trick that I discovered not that long ago. So everybody who's got a shell open, all right, I want you to type the word clear, C-L-E-A-R, all right, which is just going to clear whatever you have. It doesn't remove it from the buffer. It doesn't remove it from the history. It just clears it from the screen. Now, I want you to hold the escape key down. For those of you on the new touch bars, that's a soft button that shows up, right? It's not a hard button, right? Hold that down and just hold it, and you'll see something happen. So what happened? Right? So what you see is when you held it down, it asked you if you wanted to display, and in this case, this system I used, there are 1,375 possibilities of bash commands. Right? Now, you may get different numbers, right? Because it's based on the version of the OS you're using. And again, full disclosure, I'm on a very early beta of an OS. I'm not going to tell you. All right? So I have that many commands available to me. And if I answered yes, it's actually going to go and scream them out for me. And what it does is, you notice there's a more there. It does that so it doesn't just run past me. Right? Because that's one of the problems when you're doing a read command for a file, is if you don't put a buffer in that says hold it at a certain point, it'll just keep going to the very end. So if I'm reading a file or a directory that's huge, you know, it's very possible I could sit there and go, give me that, and I'm going to wait 15 minutes while it just keeps scrolling past me. And I do have directories that big, all right, on some of my storage. All right. So in this case, the more command is implied automatically, and what that does is it creates a screen buffer. So whatever your terminal opened right then and there, it says it'll give me a screen full of that, what's available, and wait. And when I hit the space bar, it's going to say, give me the next screen full. And it'll keep doing that until it gets to the very end. Or I tell it a command like Q for quit or Control-C to end the process. All right. So this is a little trick that, you know, you can actually use as if you want to be really nerdy, you can say, all right, get on your friend's system and find out how many commands are in bash for him or her, and say, okay. And then say, all right, I bet you don't know how many commands are available to you. And, right? And say, no, well, I don't know, thousands, what? It's like, no, I bet you I can name it exactly. All right? So, and they're buying, if you can do it right. All right? So it's really it's a neat little trick, and it goes to show you that there's tremendous amounts of commands available in every shell. Now, this trick works for the bash shell. I've not tested it against other types of shells, so it may not work for, say, like Z shell. All right? But for bash, which is our default, it's really helpful. All right? So what's really important about that is because, you know, basically every command that we want to be able to run on the computer, right, there should be, or very often there is, not always, a manual page or a man page. Right? Now, these things are invaluable to us because as we're learning to work in this environment, we need to be able to say, you know what, I don't remember all the verbs or all the options that are available. So I'm going to show you something. I'm going to look at something and say, okay, I want to look at, let's say, the ls command. You want to speed it up? Okay. 10 minutes? All right. So I'm notorious for over content, so there's a lot more that we'll go through. I'm going to speed it up a little bit to get through this. So the man page, right? So if you type the man command, and I go man space, and I say ls, it's actually going to go through and show me. And you can see on the screen, I see a bunch of things. But the trick I want to show you is that the Mac introduced a few OSs ago this really cool feature, and that is everybody with a computer open right now with terminal, type the ls command, but don't hit return. Highlight it and right-click on it. Now you're going to see something new that you may not be aware that was there, and that is, as you can see in the little screenshot there, it says Open Man Page. I can't tell you how much of a wow moment that was for me, because normally I would have to have two terminals open. I'd have one open for the actual commands I'm running, and I have another one open I would reserve for the man pages. I don't need to do that anymore. I just go and right-click on the command. So I can often type in the command quickly in the shell, right-click and say, give me the man page, and boom, it pops up. And it stays there until I close it. Right? Now, by no means is that all of it. That's just a small snippet of what's there. All right? But also I want you to see another option, which is really cool, and that is open the man page index. Now, in terminal, if I said APROPOS space ls, it would go through and say what's an appropriate command similar to ls or leverages ls. It would tell me that. All right? You know how long it took me to remember that command? I use this one by default because it just doesn't, I don't have to think about it. It goes, you know what? It's similar to this command, but I don't remember what the other options are. I can do that, and you notice I get this massive list that shows me that. Either it's a command that's leveraging ls or it's something else. All right? So now I want to quickly run into it and say, when we want commands to see what's running, we're going to look at top, we're going to look at ps, and we're going to look at lsof. And forgive me, I'm going to speed it up a little bit. So the top command tells you what you're currently running. When you run top in your terminal, the first thing I want you to notice when you do that is it stays there and continually runs. So it has a timer that it goes through and it's checking back and over and over and over again. Now there are ways of saying you can control how often it refreshes, but it is not a once and close. It is launch and continue until I tell it to quit. So you can see here that it shows me I got a process ID, what the command is, how much the CPU is, right? These things are really important. In the next session, I'm actually going to go through and show you why and how I use that information to track down problems. All right? The PS command, this command is actually used to specify processes that are running. So if I run PS by itself, when you see, it tells me I've got a terminal running. If I run PS AUX, it'll actually show me the different users that are running. So you can see I had a _ Windows server, then my account. Again, there's much more running than I show there, but I want you to see that. And if I run PS, this is a test. For the next 60 seconds, your terminal will shut down. All right, PS AUX, and you notice there's a new concept here, and that is the bar. That's a pipe command. That's a way of saying I want to do something in addition to what I've just typed in. So I'm saying PS AUX, pipe it to more. It's that buffer program. So when I do that, that's going to show me in small chunks. I can look and see what's running. All right. Last command I want to show you is lsof. All right. Real easy to remember that. ls is list, of open files. So if I want a list of all the open files that are on the computer, that's a command I want to use. Why is that really helpful? If I have a computer that won't shut down, no matter what you do, it just like something's preventing it from shutting down, that command will help you find that process. And in the next session, I'll show you how to, the different ways of looking at that and finding that stuff. All right. So you can see here, I put in, it shows me the command. It shows me a process ID, the user, right? The FD type, which I'll explain a little bit more in the next session. So there's a bunch of information that I can leverage and use. And so I've given you 3 different types of commands that I use regularly when I'm working on a user's system remotely. Because I have one user that has a problem where they can't shut down. They go to tell the computer to shut down at night. And as much as I tell them you need to dismount the network volume because it has an open file. And if you go before and try to say dismount the network volume, it'll actually tell you there's an open file still. That's why, and what app it is. Well, I'm able to use this to work with the user and say, yeah, you've got the share still mounted. You have an app that's still actively using this share. I often do this to myself because I use terminal so much, so I will forget. I will mount a network share. I will LS it through terminal through that network share, and later I'll go to close it, but I didn't close the terminal. And the first thing it'll say is, yeah, I can't dismount because it's an active process still. Terminal, even though it's not doing anything, is holding it. Okay. SSH. So SSH is our gateway to solving a lot of problems on remote systems. Everything we've been discussing has been local. Now, if I want to do that on somebody's remote, I need to be able to SSH into the system. And I bring this up because I want you to see that remote login has to be turned on. If you do not have remote login turned on, you can't SSH in. All right? So you can set that from the terminal if you had it locally, or you just go in and make sure that the users get that turned on. And notice I grouped it and said only users with administrative access. Why is that important? Because I want to make sure that group is the only one who can do that, and I don't give admin rights out to our environment. All right? So there's an SSH command in process. You can see I used an account to log in. Now what can I do with it once I'm there? I can actually do something like disk-util. All right? Disk-util is the terminal command for disk utility. It has a bunch of flags, so if you looked at the man page for disk utility, or if you type disk-util-h, I think it is, it would actually tell you what all the commands are. And notice here I did a disk-util and I typed the word list. It actually shows me how my drive is partitioned. This is important because if you're trying to diagnose a problem, you want to know what you're looking at, and I can do certain commands from disk-util. I can verify the volume. If I find a problem, I can do a repair. All right. And the last thing I want to show you is how do I know what OS the user has? You know, so a lot of times I'm dealing with multiple versions of the OS level out in my environment. So I have a simple command, sw_verse. Send a software version. It'll actually come back and tell me, all right, on the system that I did this on, notice it tells me the product name, I know the product version, I know the build version. If I do uname, all right, uname is a command that tells me a little bit more information about also the hardware. So if I did uname, it tells me the name of the operating system. In this case, it's the open source Darwin. But if I put a flag on it, you notice it says Darwin. Notice that computer is a different name than I showed earlier. It's telling me a bunch of information that I can go through, including XNU. Everybody here know what XNU is for?
Southern Methodist University.
Yeah, yeah. So that's your kernel. And if you're not familiar with kernel, that's what the hardware uses to do certain things before other commands could run. So it's the foundation for the OS that tells the OS what it can do. So it identifies the hardware. All right? So that kernel updates on a regular basis. The problem is you probably don't notice it, but it makes a difference if I'm trying to trace down a problem. So I'm sorry I rushed to the end of that, but that's the very end. Here is my info. You can reach me. That's actually my work email address. I am not afraid to give it out. You can link to me in LinkedIn. All right, I encourage that. All right. So
we'll take one or two questions, and we're going to do a quick break, and then Leon will be back for more in-depth troubleshooting.
How do you get out of the top command, or do you just have to close the window?
Q, right, or Control C, right?
Work for James Bond. Any other questions for this session?
Okay, Em.
So we're going to do a quick 10-minute break, and then Leon will be back. Thank you very much. Big hand for Leon.